Welcome to This Explainer. Today we're jumping right into a subject that is the absolute heartbeat of site reliability engineering. We are talking about incident response. Look, if you're a cloud architect, an SRE, or if you're wrestling with Kubernetes clusters on a daily basis, you already know the deal. Designing these systems, that's really just half the battle. The other half, the truly intense half, is keeping them running when a major cloud region suddenly goes dark.
Okay, let's dive into this with a fundamental law of physics in software engineering. Incidents are inevitable. Preparedness is optional, right? In the wild world of distributed cloud architecture, hoping things won't break is just not a strategy. Systems will eventually fail. Your power lies entirely in how you prepare for that exact moment.
So, here's our roadmap for today. We'll start with the inevitability of failure, define what incident response actually is, walk step by step through the incident lifecycle, track some key metrics, and then wrap things up with enterprise resilience best practices. Let's get moving.
Section 1. The inevitability of failure. We need to completely shatter this illusion right now that highly reliable cloud-native systems somehow never break down.
Because, let's face it, modern cloud-native environments are just way too complex for perfection. I mean, you've got infrastructure outages taking down entire availability zones, you've got cascading dependency failures, sudden DNS routing disruptions, and of course those terrifying zero-day security incidents. It comes at you fast. It is literally never a question of whether incidents will happen. It is strictly a question of how effectively your teams are going to respond when those alarms inevitably start going off.
Moving to Section 2, Defining Incident Response. Basically, what do we actually do when it all breaks? Now, what's really interesting about this slide is the overarching philosophy it represents. Reliability is truly tested in failure. You prepare, you practice, and you improve. This entire operational battlefield basically relies on three critical pillars: detect, respond, and recover. It's this massive, comprehensive journey from the very first alert firing off in your observability platform all the way through to continuous learning and platform engineering integration.
Formally speaking, incident response is the structured process used to detect, investigate, mitigate, recover from, and ultimately learn from operational disruptions. And I really want to highlight that word, structured. Effective response is absolutely not about hero engineers scrambling in the dark at 3 a.m. It's about predictable, heavily engineered processes that minimize downtime and protect the customer experience.
All right, Section 3, the incident lifecycle. Let's look at the chronological journey of how an incident actually unfolds.
Like we said, a structured process is our absolute best defense against operational chaos. This continuous lifecycle flows through 5 major phases. We've got detection, triage and escalation, mitigation, recovery, and finally, the post-mortem and learning phase. And remember, these aren't just isolated one-off events. They form a continuous, evolving feedback loop.
It all starts with detection. Listen, you absolutely cannot triage what you haven't detected. In modern architecture, this means leaning heavily on robust observability platforms, comprehensive telemetry, and highly tuned alerting. If your platform engineering team hasn't dialed in this observability layer, well, your customers are going to be the ones telling you your system is down. And that is a position you never, ever want to be in.
Okay, so once an issue is detected, we enter the core response phase, triage and escalation. This is the high-pressure zone, for sure. Teams have to rapidly assess severity levels, figure out the actual scope of the business impact, and execute escalation models to pull the right on-call engineers into the war room. And they have to do all of this without creating a chaotic, noisy environment where nobody knows what's going on.
Next up, we hit mitigation and recovery. Mitigation is all about stopping the bleeding. Think failing over traffic to a completely different availability zone just to reduce the immediate impact. Recovery, on the other hand, is the complete restoration of normal services. This right here is where automation really shines. We're talking about utilizing GitOps for automated rollbacks of a bad deployment or leveraging Kubernetes self-healing orchestration to just get everything back to a healthy baseline.
Which brings us smoothly to Section 4, Key Incident Metrics. Let's talk about how we measure the response.
And this brilliantly illustrates exactly what you need to track. Because to know how effectively your team is responding, you literally have to measure it. First, we have MTTD, or mean time to detect. Basically, how long does it take for your telemetry to realize something's busted? Next is MTTA, mean time to acknowledge. Once that alarm fires, how long until a human, on-call engineer, actually starts investigating? And finally, MTTR, mean time to resolve. From the start of the incident to full service restoration, how long were your customers actually feeling the pain? Mature organizations obsessively track these metrics to drive those times down. Finally, Section 5, Best Practices for Resilience. How do we proactively build this mature response capability?
See, truly successful enterprise organizations don't just react to problems. They proactively build resilience into their DNA. They define crystal-clear incident roles so everyone on the call knows exactly who the incident commander is. They heavily automate their alerting. They maintain runbooks as code, those step-by-step technical guides for known issues. And crucially, they conduct incident simulations, like chaos engineering. Maintaining those runbooks and automating alerts, those are simply non-negotiable if you want fast recovery. But honestly, perhaps the most vital practice happens after the fire is completely out, the postmortem. Teams absolutely must conduct a deep root cause analysis, and the absolute key here is culture. It has to be a blameless postmortem. We aren't looking to figure out whose fault it is or point fingers at an engineer who pushed a bad config. We are looking to figure out where our systems failed our engineers. Fostering that kind of psychological safety, that is what creates genuine, lasting organizational learning.
Let's move to and see how this builds into a bigger picture. It really comes down to two opposing forces. On one side, you have the inevitable reality. Complex systems will fail. Full stop. On the other side, you have your organizational choice, incident preparedness. You can't control the failure itself, but you have 100% control over the choice to invest your budget and engineering hours into actually being ready for it.
So the crucial point is that when you make that investment, the ROI is massive. Mature incident management practices drastically reduce your MTTR and minimize overall downtime. But even beyond those hard technical metrics, you achieve significantly less burnout for your on-call SREs, and you build drastically improved customer trust. Listen, customers don't expect perfection, but they absolutely demand reliability and transparency when things inevitably go sideways.
I'm going to leave you with this somewhat provocative thought. Somewhere in your cloud architecture right now, your next system failure is already scheduled. It's just sitting there, waiting for a specific load spike, an unpatched vulnerability, or a random dependency timeout. It is coming. Are you ready? To build a truly mature incident response capability, take a hard look at your telemetry today, automate those runbooks, and foster that blameless culture. Thanks for joining me on this explainer, and as always, keep building resilient systems.